So for which quadrants will your calculator display the inverse cosine? Do you guys remember? Inverse cosine displays angles in which two quadrants? They all the inverse trig ratios are displayed in quadrant 1. Okay, the inverse sine and inverse tangent are quadrants 1 and 4. The inverse cosine is quadrants 1 and 2. Okay, so here we're expecting our angle to be located where it'll be between 90 and 180 degrees. So we expect it to be located here, okay, which means when we calculate this on the TI-89, it'll actually tell you that angle measure. You expect to see the actual angle. So if I know that the cosine of theta is negative 0.84, that means the angle itself can be calculated using the inverse cosine. And when I actually do the calculations for this inverse cosine of negative 0.84, I want to turn it into degree mode because I'm working in degrees here. Okay, and I get my answer to be 147.14 degrees. Okay, so is that consistent with what we would expect here? Yeah. Okay, it fits between this set of information. Okay, what if, though, I asked you to find this angle so that it would lie somewhere between 180 and 270 degrees? Okay, so this is the kind of problem now that would cause a little more confusion. Because now, again, the cosine is negative means it's either going to be in quadrant 2 or quadrant 3, correct? These are the two quadrants in which the cosine value, the x's on the unit circle, are negative. So we're looking for the angle that would have the same x coordinate but would lie in quadrant 3. So we're looking for this angle down here. If we pass the line through our terminal side, we have the same initial side. So we're looking at this angle all the way around. So this is the actual angle from the second part of this problem, or the second version of this problem. Okay, so if we want to find this whole angle, the way that we find it requires reference angles. Okay, and so there's a couple different ways you have to apply the reference angle here. First, we need to take this reference triangle formed up here and find the reference angle, theta prime. Okay, how can we find this angle right here? The angle that's formed off the x-axis and the terminal side of our original angle, the angle that was given by the calculator. Okay. Perfect. We can find it by going this full rotation to 180 and then coming back to the ending, the terminal side. So 180 minus, so if we want to find theta prime for this one, we take 180 minus the angle that we found, or the angle that our calculator shows us. So on here we can just take 180 minus this angle, and that gives us 32. So we get our reference angle to be 32.86 approximately. So once we have this reference angle, what we have to do is understand that the reference angle that's reflected across here in the triangle that connects the terminal side of the angle we want, not just the angle that our calculator shows, but the angle that we want, is going to be the exact same reference angle. Okay, so in order for us to find this measure of theta, we need to take this rotation of 180 degrees, and what are we going to add to it? This reference angle that we just found, which was 32.86. So the actual angle that we're looking for here is going to be 180 plus this measure that we just found. So if we take 180 and we add to it this kind of running total, we get the actual angle that falls between 180 and 270 of 212.86 degrees. Okay. So again, it's multi-steps in that kind of a problem. You do need to pay careful attention. Which angle is your calculator giving you? How do you manipulate that angle to find a reference angle? And then what do you do with that reference angle to find the actual angle you're solving for? All right, so let's do one more example of this and see if you can solve the following for theta. Okay, this time I'm giving you the conditions, the restrictive conditions in terms of radians. So your measures need to be in radians for this as well. All right, when you're dealing with inverse tans, the inverse tan is going to be determined in quadrants 1 and 4 on your calculators. However, when we look at this, we want the angle that falls in quadrant between pi over 2 and pi. So we're looking for the angle that falls in quadrant 2. Okay, so here's the angle that we're finding. So in order for us to identify this, we need to calculate, use the angle that's going to be the angle that your calculator will show us that has a negative tangent is going to be in which quadrant, 1 or 4? So negative tangents are in quadrant 4 and 2. Okay, so the calculated value is going to fall in quadrant 4. So if we know that the tangent of theta is negative 2.4, we can solve for theta by taking the inverse tan of that ratio. And by doing that, again, green diamond T gives us negative 2.4. Oops. Okay, we want it in radian mode, so I'm going to shift or change my mode into radians. And when I do that, I get my answer. Theta is equal to negative 1.176 radians. And so that means that the reference angle is rotating down here. This reference angle right here is 1.176 in the negative direction. And notice I didn't label it as a negative here because the rotation is occurring in the negative direction. But when I find my reference angle here, I am going to just use the magnitude of it. The direction doesn't matter. Okay, so when I look at this, here's my kind of reference triangle. So when I compare that reference triangle to the angle that I'm actually solving for, this original angle here, my triangle is formed with a vertical line straight down to the x-axis. These two reference angles have to be the same thing. So this measure right here is 1.176. And so how would I find this total theta value? If I rotate all the way to 180 degrees and then I have to come back 1.176, okay, and we're dealing in radians, so I'm going to take pi. Pi is my full rotation, and then I'm going to subtract from that this 1.176. So I'll just highlight that whole value. I can delete the negative sign because I only needed the magnitude of it. Okay, so pi minus 1.176 is going to give me what's left for this theta value, which is 1.966. Oops. And these are radians. Okay, and you can test and see, again, pi is about 3.14 over 2. If you were to look at that value, is a little over 1.5. So does 1.966 fall between those values? Yeah, so it's consistent with what you would expect from that.